Hi, this is Algebra 1, Module 5, Lesson 9, Practice Problems. First, we're going to review some geometric figures. So, a quadrilateral with only one pair of parallel sides. If there is only one pair, that would be a trapezoid, H. It looks like there's 8 things, so one for each. So I've already used that one. All right, number 2, all of the sides of this triangle are the same length. Well, triangle is going to be equilateral, B. Those two look different. Next, 3, all of the sides of this quadrilateral are the same length. Well, the only quadrilateral four-sided figure that has the same length would be G square. This triangle has exactly one right angle. Huh? Right triangle has one right angle. Looks like a D. 5, this quadrilateral has four right angles. Well, that would be a rectangle. No more specifics than that. None of the sides of this triangle are the same length. Scaling means it's the different lengths. 7, this quadrilateral is both number 3 and number 5. Oh, wait a minute. Four right angles and four sides the same length. I messed up one. 3 is not G, 3 is F, rhombus. And square would be the one with both same length and four right angles. See, double check ourselves. See if you're paying attention. 8. Only two sides of this triangle are the same length. Isosceles is the two-sided. All right, next. Solve each system of equations using elimination of a variable. So you have to use elimination on these. So let's start with this first one. I have two x's there and two x's here. So I'm just going to go ahead and subtract these guys. 2x minus 2x is nothing. 1y minus 2y is negative 1y. 3 minus 2 is 1. So y would then equal negative 1. And I need to plug in y so I can get my x. So 2x plus negative 1 equals 3. So I'm going to add 1 to each side. 2x equals 4, so x equals 2. So my solution to this one would be 2 comma negative 1. Next one, we have two y's that are the same. Both of our y's have 5. So again, I can just subtract them as is. 2 minus 1 is just an x equals 3 minus 6 is negative 3. So x is negative 3. And if I plug in, I'm going to do it in the second one, so I have less numbers to work with. Negative 3 plus 5y equals 6. I'm going to add 3 to both sides. 5y equals 9. So that means y equals 9/5. So my coordinate for this one would be negative 3, comma, 9/5. Or let's see, 1 4/5 if you wanted to do a mixed number. Okay, none of these match. So I am going to go ahead and double my bottom one. So 2, make this a 4. 8.5 times 2 is 17. So I'm going to go ahead and double that so I can subtract them. 2x minus 2x is 0. Half minus 4 would be a negative 3.5. And that equals 3 minus 17, which is a negative 14. Oh, forgot my y there. So divide by negative 3.5. 14 divided by 3.5 is 4. So y equals 4 in this case. And so if I go back to my original, erase this for a second. Okay, so I had x plus 2y. So I'm going to go back to that and go x plus 2 times 4 equals 8.5. Well, x plus 8 equals 8.5. X has to be 0.5, 0.5. So this coordinate would be 0.5, comma, 4. And our last one, let's see. The ones match, but that doesn't help us eliminate a variable. So let's multiply our x by 3. So 3x, 2 times 3 is 6. Negative 1 times 6 is, or sorry, 3. Negative 1 times 3 is negative 3. Okay, so now I can subtract them. The 3's cancel. 5 minus 6 is negative 1. Y. And negative 1 minus a negative 3, which is really adding, would be 2, positive 2. And so that means y equals a negative 2. So if I'm going to plug that into my original, x plus 2 times negative 2 equals negative 1. X plus negative 4 equals negative 1. Well, I need to have, we'll just go ahead and show the work. Plus 4, x equals positive 3. So my coordinate would be 3 comma negative 2 for this one. All right, practice our elimination on there. Oh, a couple more. This one here, we don't have two that are the same. So since this is just an x, let's multiply this whole thing by 3. So I'm going to go ahead and do 3x. 2 times 3 is 6. Oh, look at that. Negative 4/3 times 3 actually cancels out those 3's, leaving me just a negative 4. That works out. Those 3's cancel. 5 minus 6 is a negative 1y. And if I have negative 3 minus a negative 4, that is actually a positive 1. So y would then equal negative 1. All right, so let's substitute in x plus 2 times negative 1 equals negative 4/3. Guess I didn't have to use a fraction, but that's all right. X plus negative 2 equals, and I'm actually going to put this as negative 1 1/3 because that'll be easier for me to, you know what? Actually, let's just practice with our improper fractions. Negative 4/3. So if I add 2 to the side, 2 in terms of 3, so 3 would be, uh-oh, what happened? There we go. 3 would be, 3 over 3 would be 1. So 6 over 3 would be 2. So this actually, if I have negative 4 plus 6, x would equal 2/3. So that worked out okay to not have it as improper, comma, negative 1. There. And this last one, it's a word problem, but we have to figure out what our system of equations is. So a 150-yard pipe is cut to provide drainage for 2 fields. The length of one piece, A, is 3 yards less than twice the length of the second piece, B. What are the lengths of the 2 pieces? Well, I need A, A plus B is 150 in length, right? And then the next one is if the length of one piece A is 3 yards less. So A is 3 yards less, that's a minus 3, then twice the length of the second piece, twice the length of B. So that's 3 less than twice the length of B. To do this as elimination, I actually need to get my 2B on this other side. So I'm going to rewrite this as A minus 2b equals -3. So I'm going to go ahead and erase it here that I can rewrite a minus 2b equals -3. Okay, so I have an a, single a on each side. So I can go ahead and subtract these. B, so 1 minus a -2 is 3b equals 150 minus 3, which is 147. And so if I take 147 divided by 3, I get b equals 49. And, right, 150, oh, minus a -3. Minus a negative is actually plus a positive. That's 153. So 153 divided by 3 is 51. There we go. Double check our work. And if 51 plus a equals 150, then a must equal 99. So my two lengths um, are, we'll just circle a different color here since it's not really a coordinate. A is 99, B is 51. All right. For each graph, determine if the relationship represents a function. If it is a function, write yes. If it is not, explain why it is not. All right. 15 is a yes. We can go across, and we only have one x value, one y value for every x. So that works. 16, if I'm going along, oh, look, right here, I have 2 points. So this is no. Let's see, -3 has 2 y values. Okay, 17. As I'm going across here, it looks like each one of these has only 1 point. So yes. 18. Oop, 18. We'll scoot over here. Nope, look at this. There's doubles all the way around. No. All, I'm going to type these because these are a little bit longer. No. All the positive x values, inputs, have 2 outputs. Right? Every time on here, even through the 0, they all have 2. All right. So on this guy, notice how it's coming down and then it skips up here. So it is discontinuous, but this point is not, it's only one answer. So -6 matches with 4, and that's it. So I'm going to put yes on here. And then for 20, if I'm following this, yes, it kind of is bouncing around funny, but there's only 1 point for each x. So this one is a yes. All right, that's it for today. Thank you for joining us, and we'll see you next time.